Okay, so we're going to work on Lesson 12, Systems of Equations. Let's get started. How do we determine the number of solutions? Well, in Algebra 1, we learned that we could have 3 sets. One solution, where 2 linear functions would intersect and create a coordinate point. We learned that we could have infinitely many solutions, and that's when the equation is the exact same, but maybe a multiple of it. This is infinitely many solutions. And last but not least, we have no solution. Graphically, that looks like 2 parallel lines. And we have no solution because the lines will never intersect and create a solution. But what happens if we were to give you a parabola and a line? How many solutions would you have? I'll let you think about that for a second. Okay, that was about 7 seconds, but here we go. If we had a parabola and a line, do you agree that that might create 2 solutions? Or if we had maybe even an absolute value, do you agree we'd again have 2 solutions? Because we have a symmetric graph with a linear equation going across it, and again we have 2 spots in which those 2 graphs connect. This is the extension of where Algebra 2 is hitting. You've learned the other 3 in the past, so now let's try it in an example. What if we asked you to solve the system of equations where y equals x squared minus x plus 10 and y equals 2x minus 2? I encourage you to pause and solve, then see how I solve it. Here I go. I know that the letter of y equals the letter of y, so I can start there by saying, since I know that y is equal to y, then I could set the first equation, x squared minus 6x plus 10, equal to the second equation, 2x minus 2. From there, I realize that this looks like a quadratic equation, so I'm going to move everything to one side, set it equal to 0, and solve. So I get x squared minus 8x plus 12 equals 0. Now, since this equals 0, I have to find which x values would make that true. Well, this is a factoring question, so I have to say, okay, what 2 numbers are going to multiply to positive 12, but add to negative 8? Do you agree that that's going to be, so again, negative 12, positive 8, negative 6, negative 2? Oh, Weissmuller, you're messing up. Ay. Let's retry that, Weissmuller. Okay, we have the x set up, and we have 12 on top, negative 8 on the bottom. So what 2 numbers are multiplying to positive 12 that add together to negative 8? Hopefully we say negative 6 and negative 2. From there, we say, okay, well, that's x minus 6 times x minus 2 equals 0. So therefore, x must either equal 6 and x can equal 2. But that's not what the question wants. The question wants us to solve a system of equations. So my goal is to, and I'm going to write my goal at the top because it's important to remember, my goal when solving is to write a coordinate solution system to the system, right? This is a coordinate. Now remember on the previous slide we talked about if we have a quadratic and a linear, we're probably going to have 2 coordinates. So our goal is to find 2 coordinates. Well, we have 2 x's, so we know that this is 6 and we know this is 2. Now we have to find the y values. Do you agree that that means we're going to take the x values we have now and substitute them into one of the 2 equations to solve for y? I'm going to pick the bottom equation because it looks easier. So I got y equals 2 times 6 minus 2. Well, then y is equal to 12 minus 2, so then y is equal to 10. So when x is 6, y is 10. Let's do that again, but now with the other variable. So we have y equals 2 times 2 minus 2. Oh, that's a lot of 2's. So y equals 4 minus 2, or y equals 2. So my solution to this system, given that I was supposed to solve, is 2 coordinates, 6, 10, and 2, 2. Moving on. Our solution to the previous one was coordinates, right? We said it was 6, 10, and 2, 2. But what if I had a different question? What if the question I then asked you was solve with the same things behind us, but say I said solve f of x equals g of x. I'm going to claim f of x as x squared minus 6x plus 10, and g of x is 2x minus 2. To do this problem, this question is the key. This question is saying, at what x value do these functions' y values equal one another? At what x values? So when I read this question, at what x values, good, Weissmuller, add this s, good. Do you agree that that means my solution needs to be in set notation and should just be the x values that I got, 2 and 6? If you do, nice work. Nice job. Let's move on. So what are the methods of solving systems of equations? Back in Algebra 1, we learned these. We know that we have one option, which is called substitution, the one we just did. We have a second option, that's called elimination. And the third method, that's called graphing. Now, when do I use what method, right? Well, substitution seems like it was really easy to do when it had something like y equals and y equals. Some might argue that graphing would be a good option to do there too, but what if I had, like that previous problem, a quadratic and a linear? Wouldn't it be easier to use our substitution as we just did? Question mark. So when do we use elimination? That's the question I want to get to, because elimination is a fun one. Elimination typically gets used when we have a ax plus by equals c equation, or what we call standard form. We use elimination so that we can eliminate a variable, solve for another, and then quickly plug that answer in to solve for the second variable. So moving on, let's do some actual examples. Example 1, solve this beautiful system. 5x minus 2y equals negative 22, and negative 15x plus 6y, oh good, Weissmuller, you didn't write equals 1. Sorry, equals 1. That's why you read your problem to make sure you actually wrote the problem correctly. So, when looking at this, thinking about my ways to solve, I could do substitution, but that's going to be kind of hard. Nothing's isolated. No variable is isolated. Graphing, well, that's going to be really rough. But what about elimination? I could quickly multiply the top row by 3 so that I can eliminate x's. So let's do that. So we have 3 times the top row of 5x minus 2y equals 3 times negative 22. Now that becomes 15x minus 6y equals negative 66. I'm going to add that with the original I had, negative 15x plus 6y equals 1. When I add these systems now straight down, I realize that I have 0 x's plus 0 y's, and it equals negative 65. So doesn't that mean that we would have 0 equals negative 65? And is that a possible solution? Like, can 0 ever really equal negative 65? I hope you're talking back to this beautiful recording and screaming, "No, Miss Weissmiller, no! 0 cannot equal negative 65. That's absurd." This is known as a false mathematical statement. Now on blend, we have that if it's a false statement, then this indicates that we have no solutions. If you don't have that part of your notes in there, I encourage you to pause this video, go to blend, and write those two statements in your notes. So moving on to example 2. Example 2 says solve y over 2 equals 1 minus 2x and 5x minus 3y equals 28. So the F word just popped up, fraction, right? Y over 2. So could I rearrange that equation such that it just says y? Yes, you got it. We would multiply everything by 2. So right now we have y over 2 equals 1 minus 2x. But let's eliminate the denominator of 2 by multiplying both sides by 2. Then this takes care of that beautiful. And it cancels so that I get y is equal to 2 minus 4x. So now I know what y is. Now that's helpful because can't I substitute in y for this y that I see here? So let's do that. We have 5x minus 3 times 2 minus 4x, and that equals 28. From here, we solve for x. 5x minus 6 plus 12x equals 28. Combine your like terms, so we have 17x minus 6 equals 28. Add 6 to both sides, 17x equals 34. Divide both sides by 17, x equals 2. Do they only want an x value? Good, no. They want a coordinate. Remember, we're solving a system of equations. Now, these are two linear equations, so once we have x comma y, we're done, because two lines can only cross at one intersection point. So now let's solve for y. So now that I know x, well, can't I go back to my y equals equation? Y equals 2 minus 4, but now I know x is 2. So doesn't that mean that I have y equals 2 minus 8? So y equals negative 6. My solution to this problem is then 2, negative 6. Okay, we're on to example 3, the last example of this lesson. So example 3 says solve, and then you really got some fractions here. We have 6 over u minus 3 over v equals 4. And then 8 over u plus 6 over v equals negative 3. So we're going to do something mathematical today that's kind of new. It's called a let statement. A let statement means I'm going to make a mathematical statement about what I don't like in my current mathematical statement. So I'm going to let x equal 1 over u, and I'm going to let y equal 1 over v. Now that's because I have this fraction, and I'm going to write it off to the side so we can see it. I have 6 over u, but doesn't that equal 6 times 1 over u? And I have 3, negative 3 over v. Well, doesn't that equal negative 3 times 1 over v? And then thinking about that and letting x equal 1 over u, well then can't I write my first equation as then 6x minus 3y equals 4. Similarly, the next one is 8x plus 6y equals negative 3. Now, how many of you like that a lot better? I sure do. So now it looks like I could eliminate my y's, but I would need to multiply my first equation by 2. So I'm going to do that, and I would get, if I took this equation and multiplied the entire thing by 2, my product would then be, good Weissmiller, wrong number, 12x minus 6y, which equals 8. This is me taking the first equation, multiplying it by 2, and writing that in green. Now I'm going to eliminate, so now I'm going to use these two beautiful equations, and I'm going to eliminate my y. So here we go. Eliminating y means that I'm going to add straight down. So what's 8 plus 12? Well, that's 20x. Eliminate the y's, which equals now 8 plus negative 3. Well, isn't that 5? Yes. So then divide both sides by 20, and we get x is equal to 1/4. Okay. So now if I have x, can I find y? Absolutely. We have 8 times 1/4 plus 6y equals negative 3. Well, do you agree a fourth of 8 is 2? 2 plus 6y equals negative 3. Isolate 6y equals negative 5. Isolate y equals negative 5/6. Now go back to the top of your question. Did they want x's and y's? No. So I'm going to need to use my let statement and my solutions that I just wrote down, and I'm going to have to actually solve for these two beautiful things. So here we go. I'm going to go to the next slide, and we have the original said let x equal 1 over u. Let y equal 1 over v. We got for x that it's 1/4. So 1/4 equals 1 over u. Well, doesn't that imply that this number must be u? Because 1 over something equals 1 over u. So therefore u equals 4. And we got for y negative 5/6, and that equals 1 over v. Now to solve for v, I can cross multiply, and I get negative 5v equals 6. So v equals 6 over negative 5. Now how do I write this as a solution? Because this is not x, y. Well, we like to write them alphabetical. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T, U, V. So it always goes U, then V. So my answer to this would be 4, negative 6/5. Folks, have a wonderful day. Thanks for tuning in.